So nobody ever asks me why the second channel on my power supply is like always set to 17 volts. This is why. The reason why I have my drone out today on a cell phone repair channel, I have got a job in my job queue that pertains to drones. I know people get all weirded out over privacy, but if they actually seen what you can see from like 300 or 400 feet, they wouldn't be too worried about privacy. You're not going to see anybody's nipples. Here I've got, in my basket, I have got a drone project here. This is a tiny little, it belongs on this channel. This is a micro PCB, and this is going to be a microscope mod. It really is a tiny thing. We've got an SD card in here. I've got this labeled as a 3DR cube. This is a 3DR solo cube. And I don't know much about this at all. I have had experience with one flight controller, and that's the one that's on my drone. I don't know what this is, but I've got a really simple how-to process here as to do what I'm getting ready to do. So here's this website. We're going to be doing the 3DR Solo Cube 5-volt modification. This thing is outputting 3.3 volts pulse width modulation. And the buffers are running off 3.3 on both sides while they're capable of delivering 5 volts. So what we're going to be doing here, we are going to be breaking off a 3-volt connection and attaching a 5-volt connection, right? Okay, now which chip is it that we're talking about? If I hold this up here, put this under the microscope so you can see it. Okay, so here it is under the microscope. And I think we found our match there. So I'm going to be concerned about stuff like this. This is either a light or a sensor. So this is the picture on the website here. We've got these two chips and then this one here. So there's our 3 chips. Okay, let's scroll right on down. It shows removing this chip here. And it says cut the trace that feeds the upper left pad. So we're basically going to take it off and cut the trace. And then we're going to solder a wire to here. So basically we're going to cut 3 volts away from this thing. And we're going to solder 5 volts to it. Now where does the 5 volt output go? 5 volt output, it says the other end of the wire is routed to a clearly labeled 5 volt pad in the upper right hand corner of the Pixhawk 2.0. Hey, look at there. Top right hand corner. Right up here we've got 5 volts. My primary concerns on this one are this plastic connector that is right here very much nearby. I don't want to melt this plastic connector. And let's have a look around the board. We've got this thing over here. This is probably a light or a I really don't know. It could be a light sensor. Directly on the opposite side of the board. See, so we've got our 3 chips here. Directly on the opposite side of the board, we've got, I believe, a crystal. Do we have any openings? I'm looking for stuff I can mess up. This is not one that I work on a lot. You know, like I've never done this before, so I don't want to mess up this guy's board. Now it is fairly inexpensive to replace, but still. Okay, this is, I believe, some sort of a pressure sensor. This might be barometric pressure. And I am going to go ahead and I'm going to throw a piece of tape over that. I don't want at any point in time during this repair. You know, this isn't like an iPhone where if you mess up on a sensor like that, it's just not going to read the altitude right. A drone not reading the altitude right can be a fairly serious problem. Alright, so I've just got me a big old hunkin' piece of Captain tape over that, which I believe is a barometric pressure sensor. Okay, trying to shield my heat off of that connector the best that I can. Alright, now we're going to take a about the smallest amount of flux here that I can use. I'm going to be doing this. I'm going to do this with a toothpick. Yeah, I don't... I've spent a lot of time with my drone, but I don't have any experience with anything other than I'm using an APM 2.8 flight controller. And I've never had any issues with people getting upset over me flying my drone, but I'm also very considerate about where I fly it and how I fly it. Like, you're not going to... You know, here in the United States, it's completely legal to fly over private property. You just can't land or take off from private property. And the people that own the property can't say, hey, you can't fly over my property. You know, that's the way it is in the United States. But I'm not like a douche. I'm not going to fly it over people's yards or go look in their windows with it. All right, so we've applied a baby amount of flux to this. I am going to go ahead. I'm going to turn my hot air on because I can't hardly solder without hot air. Let's switch you back over to the microscope. Now what I'm going to do here is I'm going to begin flooding these pads with leaded solder. You know, this might already be leaded solder. It might be leaded solder. Well, okay, let's do it like this then. Let me pull my solder up off of here. Okay. My reason for switching to leaded is to lower the temperature. I don't want to have to put crazy amounts of heat on this board, especially with this connector like right there. Alright, let's see if I can just lift this up off the board. I'm going to grab a hold of it with some tweezers. It wasn't bad. Okay. And I'm going to say the solder that's on that chip looks good. So I'm not going to deal with the pins on it. Okay, I'm going to go ahead and I'm going to float these pads with leaded solder. And I'm a little bit embarrassed to say right now that I am completely out of wire 6337 or 6040 leaded solder. So I'm going to be using paste for this one. I should be doing this with wire. What am I doing? This is so much easier with wire. This is awful. Let's see if I can lift that up. This is terribly embarrassing. Am I sure I don't have any wire solder? This is so much easier with wire solder. Everybody's gonna know I'm a noob. That's better. Okay. Just want to make sure we've got good leaded solder here so this man doesn't have a drone crash because his outputs quit outputting PWM. Alright, we're getting it now. But keep in mind, I've never worked on one of these boards before. So you see all this working on iPhone boards I do and everything just kind of finesses and flows into place. That doesn't just happen overnight. That's from having a lot of time on those boards. Now we're getting good fluff here, okay. Good anchors over here. Needs a little more heat for those. There's a lot of finesse between controlling your heat, guys. So when people have issues with things flowing just right or things not sticking, it's due to heat. All right, I'm going to try to carefully clean this up because I don't want to run alcohol everywhere. And I also need to see what I'm doing, so I have to clean it up. Okay, this is actually looking really good. Dun 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 dun. Invasion of the drones. You want your neighbor to quit bitching about your drone? Quit trying to peep with their daughter in the backyard. How about that? Alright, so back over to our screen capture here. We've got that cleaned off the way that it should be. Actually, probably quite a bit better than what's shown in these pictures. Now it says to cut this trace. There's a trace that comes from underneath and goes to that first pad. Do we see that trace in here? We do. Okay, so we need to remove that connection. That's our next step. And I'm going to do it right out here in about the middle. You know, if you ever wanted to go back, I guess you could probably jumper 3.3 volts from somewhere else and not have to pull this back up off of here. So we're going to cut the trace. Sort of reminds me of modifying my Yaesu ham radio. Dear God. How deep do I have to go? That took a substantial sized trench. I'm not sure if I showed that really well. But basically I just took the trace going to this first pad here and I cut a trench across it. So basically I just chopped us out a notch. Now what we're going to do, according to the website, we're going to go ahead, we're going to put the chip back on it, and then I'm going to route a 5-volt wire over to this pin. So back under the microscope here, I'm going to get rid of my little bit of fuzz. Now we're going to take and put a tiny bit of flux across here. And we will take our IC and plop it right back on there. All right, let's begin heating this up. I have absolutely no idea where to hold this. I need to cut back on coffee. I'm doing this in the morning, like before breakfast, all I've had to eat or drink is coffee. And I think I'm going to sit here and micro solder like a champ. Alright, I think we're just about in the position here. Am I recording? Let's put this chip back on here and finish this mod for this dude. Okay. See everything starting to melt. The chip should fall into place. It does. I'm going to hit the top side here with my iron. This all looks really good. You know, the first initial soldering there was probably okay, but I don't want anything to come loose. Alright, I'm probably going to go ahead and quit playing with this one and get our jumper wire in. Alright, so there we have the chip put back on the board. The next step in this mod is going to be, we are going to route a wire in here for 5 volts. I'm having to dig in the other drawers for this one. Surely I've got wire that's more appropriately sized. Tell you what, sometimes it's nice to have a bunch of shit laying around. Okay. So we're going to be taking this wire and soldering it here. And you know, I think I'm gonna make the same turn that they made in their how-to. So we'll solder it in there first. So I'm going to tin my wire. I'd really like that to be completely flat, so I'm going to add a little bit of flux. I'm going to grab it with tweezers and I'm going to do it once more. Ugh. Every time I say a little bit of flux, I drown a board in flux. Okay. I am pretty well jittery today. And you magnify that by wherever magnification I'm at right now, and I'm real jittery. Alright, so there we've got our wire soldered on there. Now I'm going to try to carefully make a turn with this wire, and putting very little stress on the pin that's on the connector. So I'm going to grab this wire right here. And I'm going to put this bend in it. There we go. Now keep in mind too that this is magnet wire. It's got an enamel coating on it. So unless you nick it, it's not going to short against anything. But since this is going to be in a vibrating craft, we don't want to give it any chances anyways. Okay, so and this wire may be too fat a gauge, but I don't know what this is delivering in current, and takes less of my time today to just use a fatter gauge wire than it would to research and use something that might potentially be too small. Because I'm working on cell phones. I'm working on LEDs. The wire I use at most powers like an LED. Okay. Sucks after doing this I'm not going to be able to show you that it works, though. I'm not even going to know myself that it works because I don't have anything to plug this into. Okay, here we are up here at our 5-volt rail. And hold that wire right there. We're going to add a little flux. And we're going to solder it down. Trying to burn the enamel off of this wire and scrape at it. And I think we're just about there. I might have to use a larger iron for this one. That's a lot of wire. I mean, it's a big hunk of wire. My micro pencil may not cut it. Let's try the tweezers. Oh yeah. Nice. Should learn to quit the first time I say nice. I don't like it that it's up off the PCB on one end. I mean, it's still very stable. This stuff's a lot harder to cut than what I'm used to using. Good golly. We're going to leave it. All right, let's clean up the flux here. Make sure everything looks good, and then I'm going to anchor this wire down. Now, this part of the board, I'm probably going to go ahead and like totally flood with alcohol. You see I got a huge hunk of Q-tip fuzz there. Don't worry about the Q-tip fuzz. We're not worried about Q-tip fuzz bringing down a drone. We're worried about shotgun bullets that are specially engineered to bring down drones. I seen an RF device the other day. I'm always looking at YouTube for drone stuff. I watch a lot of Ken Heron. Ken Heron's funny. I'm also inspired by his video editing. See a lot of devices for bringing down drones, though. People are really spooked out by these things. I promise you, though, if you see my drone, I'm trying to stay away from you because I don't want no trouble. I am a trouble avoider. I am an anti-confrontational person. So if my drone gets shot down, that means I'm not the troublemaker. And I'm not just some dude that went out and bought me a DJI Phantom and fly that. My drone is sentimental, and if you shoot down my drone, I'm going to be pissed. Because I've got a lot of time invested in mine, and learning, and figuring out how to hook stuff up. My drone means a lot more to me than money. So I'm careful not to intrude on your personal space. Alright, da-da-da. Now I followed the directions to the T, so if this thing catches on fire, Got to sue that guy. Now there's another aspect of this I hadn't really thought about. What if I work on a drone for somebody and then it all of a sudden screws up and flies into a crowd of people? I wonder if I could be held liable for a shoddy repair. Dun, 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 almost there. I got to get this done and get to real work, guys. This one's kind of a fun job for me. That's actually a really good looking solder joint. So, to the man who sent me this drone board, you can rest assured that my solder joint will not come loose while your drone is hovering over your neighbor's pond. And there we go. We've got nice solder joints all the way around the IC. We've got our wire in place. Now we're going to make it so that this wire cannot move. Now, since the wire is already a little springy, the first thing I'm going to do is take some really quick drying super glue, and I'm going to tack this to the board. Even the tiniest little bit under the microscope here is huge. So I'm going to touch the wire with it. A little dot. This is a dot of glue on the tip of a toothpick. So I'm going to touch the wire here. And then I'm going to push the wire down onto the board. Come on, Movo. I am used to working with wire that is way smaller. My wire would not have enough tension on it to lift back up like that still is. Alright, so we'll just give this a little more time here. My wire, thin little wire, tacks down really easy. This stuff is big and bulky. Come on now. Don't make me look like a fool in front of my YouTube audience. I don't want them to know this is the first time I've ever worked on a drone circuit board. Dry, so that I can finish this job and fix iPhones. Oh, come on. Stick. I know what's wrong. This glue sucks. All right, let's get a little bit more. Okay, you freaking wire. Honestly, I cannot begin to imagine that the tension on that wire is stronger than this glue. Let's try this glue one more time. I only need it to stick for like a minute. This is just to hold it in place. And maybe I'll tape it down and wait for it to dry. All right, let's wait for this glue to dry. And give it more area. Okay. Should have did that to start with. It needed more area across the bottom for this to stick to. You would have a hard time doing this repair without a microscope. or this mod. This isn't a repair. This is a mod. Now we're getting somewhere. Now it's starting to stick. Let's give it a little longer. You know, we don't want this wire to jiggle around. Okay, that's going to be stuck. Make sure it's off of these caps. So now we've got our wire that runs from that pin on the IC. It comes around. It runs right up here and it solders to this 5-volt rail. All right, now the next thing that I'm going to do here, I'm going to be using a conformal coating to make sure that this wire does not move. This is pretty runny stuff. I'm not sure if I've got good stuff or bad stuff. I've been using this for a long time and it works really well. So now I'm going to take a drop of this stuff on the tip of a toothpick. Make sure that's down against the board. I'm going to put a drop of it right here. Here. Now, what I'm mostly concerned about here is I don't want it to rub up against anything. Like right here, I'm worried that it could eventually rub through here and begin to make a contact. So I'm going to be sure and we make sure that wire doesn't move right there. I actually try to cover the whole entire wire because we don't want it to jiggle. But we definitely don't want it to make contact through here. Okay. There we go. So we've got this green, ultraviolet green mask on here. I'm going to get a little bit more there by the connector because it looks like I just barely got the wire coated. I want to make sure this wire does not jiggle. These flying machines can do a lot of vibrating. All right, so much for not getting it on that chip. We're just going to get it right down in here. These things can do a lot of vibrating, and I want to make damn sure that this don't come loose. It's not hard to work around this UV mask if you do have to go back in and make a second repair. Or if you have to, you know, if you've already cured it up and you have to go back in and work on it again, this UV mask actually cleans away really easy. It's not that difficult to work with, so I'd much rather be safe than sorry in this case. I'm going to try to show you here what this looks like before I cure it. So here you can see we have our jumper wire in place. It goes directly to that top left pin on that chip, well, bottom right since it's upside down. And it is carefully routed around and hooks to this 5-volt rail. and we're not going to have any issues with it moving or becoming disconnected. So the next thing I'm going to do, I'm actually going to cure this up with ultraviolet light, and I actually do not have a UV lamp for curing UV glue at the moment, so I'm going to be using this lamp, and I'm going to screw this bulb into it. I'll set this here. So now I'm going to sit this over the top of our workpiece, and I'm going to leave that there for about 15 minutes. Okay. We are back with this thing. The UV mask is cured up. I'm going to go ahead and remove our tape. From the barometric pressure sensor. So it's not the prettiest thing in the world. It's actually not very pretty at all. But it is very stable, and it's not going to go anywhere during normal flight, even under heavy vibrations. This is going to be just fine. I'm going to show you what this looks like under the microscope. So here we are up here at our 5-volt connection. And that wire runs right along down side here. There might, I just took the people that wrote this article's word for the best way to do it. There may have been a shorter route to get 5 volts, but I kind of doubt it. So 5 volts runs from here, all the way down here, over and around, and to the input on this IC. There you go. So there you have it, folks. That was my 3DR Solo Cube flight controller 5-volt mod. I've now modified this thing so that it is outputting 5 volts pulse width modulation instead of 3.3 volts. But I have absolutely nothing here that I can test this with, so I'm going to go ahead and just trust that this works, get it back to the guy, and if he has any trouble, I'm sure that I will hear about it, and I really hope that it's not in the form of somebody's crashed up baby. So by baby, I mean toy, drone. Gosh, you got to watch what you say nowadays. Anyways, guys, I do thank you for watching. I hope you have successful repairs, and I will see you next time. Have a good day. I built this over the period of like 6 months, and I got a lot to say about this, but I'm not going to drag this out in this video.